Okay, generally, here's how the numbers A, B, C, D affect the graph of the parent function, y equals the cosine of x. And since we're dealing with a period of 2 pi rather, in this problem, we're told the amplitude is 2, the phase shift is pi over 2 to the right, and the vertical shift is 5 down, or a minus 5. We'll go to Desmos and take a look at what these numbers do. But to determine the value of b, which they don't give you, we have to say that 2 pi over b is supposed to equal 2 pi. And that turns out to mean that b equals 1. So when we do go to Desmos, this b will be the number 1. So let's see what's happening. Here's the graph of the cosine function, which has an amplitude of 1. I didn't put this point in here, pi negative 1. And this is one period of the cosine function from 0 to 2 pi. Now, if I define a function g of x that starts to look like the required one, first let's put an amplitude of 2. All that does is have this cosine function go 2 above the midline and 2 below the midline. And the midline in this case is just the x-axis. Now we're going to phase shift that pi over 2 to the right, which means we use the opposite sign that you might think is going to happen. There's a phase shift pi over 2 to the right. There's pi over 2, 2. So in other words, this blue point 0,1 got shifted to the right pi over 2, but it now has an amplitude of 2 units above the midline. Finally, I'm going to do a vertical shift down 5. So I'll just put a minus 5 here. And there is the graph that we're looking for. I'm going to graph the midline for the black function, which is y equal minus 5. And I'll make that dotted. And there's some of our points. So the 2 that was up here has now been shifted down 5. And that will be the case for all of these points on the graph of the red cosine function. Okay, so that's what the vertical shift does. It moves the midline up or down, and all the points on the original parent function are moved up and down. Okay.